If you ever lose your depth perception, it will freak you out. Coming up at buttons like, where are you, buttons? Okay. So everything we've done with the X bar is the formula we had earlier. There are situations where this makes sense. There are situations where we know the standard deviation, like the dolphins thing. There's an accepted standard deviation of dolphin length. So it's a known sigma. But when we come into something that we don't know anything about, right? Like we discover a new species, there's no way in hell we're going to have enough data to know what the standard deviation of everything is. So we're going to take a sample. We're going to figure out X bar and S. Now, if there's something I'm not sure about, should I make my confidence interval bigger or smaller to account for that? Bigger. If there's something I'm not sure about, like I think this fish swims this far, but I'm not sure, I better throw out a bigger net. So what that translates to is, if I only know S and I don't know sigma, I can't use a z-score. I have to use something that's always a little bigger. So like the one we did that had a 1.96 here. That's because I knew sigma. If I didn't know sigma, maybe it would be 2.03. A little bigger to cover my ass for the fact that there's something I don't know. I don't know what the real standard deviation is. So on the surface, I want this to make complete sense. If there is a piece of this I'm not sure about, I'm going to estimate the standard deviation by using S. Is S equal to sigma? Almost definitely not. It's just a sample. So what do I do to kind of account for there being a weak chain, a weak link in this thing? Is I don't use the z-score. I use something that's always a little bigger. And it's called a t-score, yeah. And the story behind this is, there's this dude, William Gossett, who was working at the Guinness Brewery. Drink a few Guinness and try to say the word brewery. Brewer. And he did a study. He wasn't allowed to, any data that he did in the company, he wasn't supposed to be able to publish it or use it for himself. So he published it under a pseudonym, Student. So you always see this thing about students' t-score. I don't know why. Now that we know it was William Gossett, he's dead, so there's nothing they could do to him. Why we don't call it Gossett's t-score, I don't know. It's still called students' t-score. That's the story behind it. So here's the t-score chart. You get the T. And we gotta learn how the hell to read this thing. 8.2. Sorry. I can just read your minds. How many frickin' charts? Was there W scores or you skipped A score, B score, C score? Don't worry. There's one more chart after this for later this semester. All right, guys. So let's. Can you get the lights again? I'm sorry. All right. So look at the very bottom of the chart, real quick. Do you see how large the sample is? I love it. Look at the very bottom. What's the biggest size sample? Large. Yeah. So the reason they're vague about it is it actually depends on the situation, how precise you want to be. You can use technology to get more than the values in this chart. Notice, what was the one we just did? 1.96 was for a 95% You remember that? That was the first problem we did. Everybody with me? 95% confidence interval was 1.96 z-score, right? Now, 95% confidence interval. When I make a confidence interval, to explain the top of this chart, how many tails do I make? Chop. Two tails. See where it says 2 tails? Next chapter, we're going to have things called 1-tail test, 2-tail test. So that's going to become important. But for 95% confidence interval, how much is outside in the tails? 5%. So look at the middle column, 0.05 and 2 tails. That relates to a 95% confidence interval. Do not write notes on this chart because you're going to use it on the test. And I'm going to look at it and be all like, who's this? Is everybody with me so far? If I wanted a 98% confidence interval, which column would I look at? 98% confidence, how much is outside the tails? 2%, 0.02. Look, if you cut it in half, then it's 1% and 1 tails, the top row, right? You almost can't go wrong, although you guys always find a way. So look at the very bottom of the 0.05. What happens as you go down the 0.05? What happens to these scores? They're getting smaller and smaller and smaller until they become, what are these? Aren't these z-scores? Haven't we seen like this one and this one? Well, this was 2.575, so this is a little more precise. 1.96 we just saw a minute ago. 1.645, you've seen that a couple times. So what's a t-score do? Why was a t-score invented? For when I have a normal distribution, but I don't know what sigma is. I only know what S is. So t-scores were invented for when I don't have the true population statement, when I only have the S. So when does S get better and better estimate? When is S a better and better estimate? When my sample is big. So it makes sense. As my sample size gets bigger, my t-score gets smaller. It approaches the z-score. It's not needed as much. If I have a really small sample, there's some big-ass numbers at the top, right? But if I have a larger and larger sample, they don't need to widen it so much. I feel better about my S estimate until I get a really, really, really large sample, and then I could just use a z-score. Because I don't need them at all then. I feel really confident about my S. Can we stop here for a second? You guys look beat up and downtrodden and confused, which is right where you should be. So let's do the next thing about this. Everybody can see how to read this now, right? We need to understand what this means. I think I talked about that before, didn't I? I'm pretty sure I used those words, no? Yeah, I did. I know I did. Just to remind you guys, if I had, if I had 3 numbers, does this sound familiar? I needed the average to be 40. How many of them can I just totally make up? 2. So I'm not going to do the whole thing again. But degrees of freedom is n minus 1. So let's try this. Let's say the sample is, my sample size is 34. And I want to make a 98% confidence interval. And I only know S sigma not known. What's the t-score that I would use? Don't say anything out loud. So that situation, see if you can use this chart. Don't say anything out loud to figure out what that t-score would be. One semester, no matter how many times I said don't say anything out loud, this old man in front of me would be like, 14, what is that? I said don't say anything. All right, so everybody got that? Everybody got an idea for it? What do you guys get? 2 high? So we got 98%, so I want this column here, right? And then n is 34, so what's the degrees of freedom? Take away my chart. You gotta take away my degrees of freedom. There. There you go. I think that's what you said. I said 2.445. Sweet. Sorry to sound so surprised. That chart's not that difficult to read. Like I said, the top, we're basically always looking at the 2 tails for right now, but in the next chapter we'll be looking at both, depending on the problem. Mohammed, what's up? Totally did. Because this isn't sample size, this is degrees of freedom. And what's degrees of freedom equal? N minus 1. Yeah. I like it. Couldn't they just put an N here? Yeah. They didn't, so hey, that's where we are. Alright, so on the reverse side of that thing, can you bring the lights back to me? Thanks, man. There's what I call the T-score lightning round. Here they are. Yeah. T-score practice. The other side of the one we just did. 81, 83. Go ahead and try to do those problems.